So welcome. Thank you so much for joining us for what we hope will be a really informative and engaging session on assessing the quality of AI in education. My name is Jared Lee. I'm the Chief Program Officer here at AIforeducation.org. I assume you know who we are, given you're at this session, but as a quick reminder, in a nutshell, AIforeducation.org is working with the Gates Foundation and others to ensure that low and middle income countries don't get left behind by the benefits of AI, and that we realize the opportunity for AI edtech to help improve learning at scale and tackle the global learning crisis with a focus on sub-Saharan Africa and South Asia. With the advent of generative AI, I think there's a few sectors that will be as deeply impacted as education will. And we've already seen an explosion of interest in this topic with governments, policymakers, teachers, and students all around the world quite abruptly finding themselves having to grapple with what the advent of AI means for them, including how we can both seize the opportunity but also manage the risks and challenges of it. And of the many issues it's thrown up, the one that we're going to explore today is around quality assurance in the context of AI edtech. So we're going to discuss what we mean by quality, how it can be measured, why it's so important, and unpack what it means in practice from the standpoint of a few different organizations. And hopefully we want everyone to come away from this with a better understanding of how we can ultimately tell which products actually work and which ones we should be adopting. In terms of the agenda, Paula, if you could go to the next page. So first, we'll hear from Maho, our COO, who will set the scene with how we think about quality in the context of AI edtech, and share some findings on the state of evidence use and quality assurance in the market today. Then we'll hear 3 rapid-fire presentations from speakers from different organizations on how they're each approaching this issue. So Will Gain, who's head of product strategy at Oak National Academy, is going to share how Oak is approaching quality assurance in the context of their work to generate lesson plans here in the UK. Then Dr. Salome Maro, who's a lecturer at the Department of Computer Science at the University of Dar es Salaam, is going to tell us about her work on voice AI in Tanzania. And then finally, our very own Ollie Garrett, who's our chief data scientist, is going to talk about our system of benchmarks and how we can test LLMs for things like their pedagogical knowledge. And you'll hear a theme that runs through these presentations around the need to feed in high quality inputs and then assess for high quality outputs. So keep an ear out for that theme as you listen to the different presentations. Then we'll have a panel discussion with 3 experts in this space, so Gori, Nissi, and Nicola, who I'll introduce at the time, to have a discussion around all of this and unpack some of the key issues. And then hopefully there'll be some time at the end for Q&A on all of the sessions, but also please feel free to comment in the chat as you go, and we will do our best to respond. We would love this work to be a sort of collaborative exercise with the community, and we would really, really appreciate your feedback and your thoughts on what you hear today. And so there'll be a link in the chat with a survey form in which you can either tell us any sort of feedback you have on or thoughts on any of the content that you hear, and also if you want to have a follow-up discussion with us on any of the topics, then there'll be a space to flag that as well. So thanks again for joining us. That's the plan. Let's kick off without any further ado. So I'll hand over to Maho.
Hello, thank you. Thanks, Jared, for the introductions, and thanks so much, everybody, for joining. I see some of you still joining, and we're very pleased to have you here. I want to start this session by talking a little bit of our work that we've been doing in the last 10 months. So we're supporting the development of AI tools for low and middle income countries, and we're focusing specifically on ensuring that these tools are grounded in evidence, they are technically robust and reliable. They are also built and designed prioritizing equity and affordability at scale so that no one is left behind, and they can improve learning at scale. What I do today during this session is to walk you through how we're thinking about our quality assurance for AI tools. Here I want to thank the Jacobs Foundation for being forward on this and supporting this work over the last year. And we also want to deep dive into why this is important and crucial as we see these tools are scaling in low and middle income countries as well. As I go through the presentations, I'll also highlight how the next presentations that are following after me fit all into our quality assurance framework and how we're all aligned. As Jared mentioned before, this is a conversation and it's a dialogue So please feel free to write anything on the chat, and as well, if you want to continue following with us, the conversation, there's a feedback form for those of you which we will contact you afterwards. So why are we focusing about assessing the quality of AI? Mainly because we're seeing a lot of numbers of teachers and students that are already using AI apps without little or no evidence on their quality or impact. And we recently conducted a mapping of AI edtech tools in sub-Saharan Africa, India, and Pakistan. And we found around 79 products. There's a little bit more that we have found, but this is increasing. And these 79 tools are already integrating AI or fully relying on AI. They are led by around 74 organizations, and we're seeing that India and Kenya are vibrant ecosystems leading the way. We often see that many of these, around 85%, are local innovators, which are often backed by organizations in high and income countries. There's more details on these 79 products, and you can see that following the QR code, which we have put a dashboard on our website with much details on these organizations. We, of course, know very little around how they are integrating AI. We know very little around mechanisms to improve the accuracy and reliance and relevance, including safeguarding rails of these tools. And very few also mention what foundational model they are using, which of course is a function of cost and size, but also should be a function around quality. What we're seeing is that in these descriptions in websites, we're seeing that AI is being used as a catch-all with very little details. And we have gone through the websites and we see descriptions, this sort of descriptions that you see there, where we see a lot of AI-powered, AI-driven words, but very little description on what they are using. Just want to say that any descriptions that you find here is, that may look like other kind of products is purely coincidental. This is just like an example of what we're seeing on these project descriptions. So all in all, very little details on how they are using the AI and what foundational models they are using. So what do we know about these tools? So we have mapped here the use cases that we're seeing coming up in sub-Saharan Africa and then Pakistan. And this comes out from the analysis of the 79 products. The numbers that you see in parentheses will not sum 79 because some of these products are targeting more than one use case. We are seeing that the majority of the products, we're seeing more products supporting students directly, generally targeting one-to-one support through chatbots and also learning platforms, so doing personalized learning. For teachers, we are seeing that lots of content generation in terms of helping teachers generate lesson plans, as well as help with some tasks that save their time. We're calling this saving and processes with a catchy name, Edufficiency, which I hope you like and we take onwards. So we're very little on supporting the wider education administrator, including schools and the education system as well. When we search for evidence and quality of these products, it's largely unknown, the quality. So we know there's few organizations that report on the pedagogical foundation. That doesn't mean that tools are not grounded in this, but they don't describe per se that in their websites. We have also seen that around 4 evaluations have TOLNA evaluations. This is particularly relevant in products in India, but none of them are shown on their websites. And we also see that some report on quantitative evaluations of the AI output, but very little published benchmarks on AI quality. So the foundational models are usually unknown. And very little report on evidence. What we see here is that 42%, show customer reviews, which of course, they rely on perhaps teachers and students talking about the relevance, but that isn't a measure as with Google reviews on restaurants. You can find a good restaurant that the reviews are not describing what you are expecting, and we will want rather to be usage and scale from customer reviews to be based on quality standards. We are worrying that scale is not being used to drive quality. So here on the y-axis, we have studies on quality, from limited to assessing product quality to measuring effectiveness on the y-axis. And then on the x-axis, we have scale. So in terms of how we want to support organizations to move to the top right, where ideally we should have, we will try to look at the organizations that are in the top left, and support them to move to the top right. If they have already proven that effectiveness works, we will want them to scale. We also want those ones to leverage those organizations that have huge scale but limited evidence, those kind of like 3 products out there when we're seeing, to then leverage that they already have reach to generate the evidence and so on. And then we also want, as a system, to know how to support those organizations where we found a lot of products in the bottom left, in terms of like limited evidence. And also emphasize that we want to move up. So what we want to show is how we think how we're thinking about quality. So I have very few minutes to go, so I'll go quickly through the slides. But on the left, we have the usual stuff around organization and team capabilities and experience and track record. That's the usual stuff. We have on the right-hand side where we want to go in terms of evidence and adding a goal in itself, that is the time saving of processes. And in the middle is where we really are thinking about quality. This is where we have found cheaper, more scalable leading indicators of who we should be supporting to move them towards scaling as well as assessing evidence. So what we're doing here is widening our concept of what evidence look like to look at having a 360 views on early indicators that are determinants of a product's ability to have an impact. And we have 3 categories: pedagogy, edtech quality, and artificial intelligence. In terms of artificial intelligence, we have 2 sides. It's the inputs quality. This is where localization and meaning adding local materials to improve the relevance of models is relevant. But as well, on the output quality, it's both measuring the AI quality of outputs as well as running standardized procedures that can be applied to different models to understand how they are scoring. And we'll have some presentations both looking at all these 3 angles following this conversation. So alongside the dimension, we're also considering the stage of development of the product tools. You'll see it will be surprised, like it will not come as a surprise, many of the dimensions that we're seeing, and we know that there are established frameworks already out there measuring different of these dimensions. So we're building on what exists, and we're also gauging what's reasonable evidence in terms of the cycle and where they are, and how also this changes by product and type of use case. And what we want to do with this quality framework is move into actionable guidance. So what we have done as a first step is writing some guiding questions to help support developers think on the areas that we should be improving. If we take, for example, the first question, does the team have the necessary expertise and experience to develop and scale the products? We will be looking there at product planning and development. And there's aspects that are coming important when we're designing these edtech tools, such as computing time, that should be taken into account in their initial plans in terms of how this is going to cost for scaling further on. There's other examples and other guiding questions that we have put our website, such that there's the QR code. The focus of today's conversation will be around AI quality. So we have 3 conversations that will be touching upon the 3 questions that you see highlighted in the red box, how different organizations are inputting high quality data to train their AI models, what mechanisms they are using to improve the model accuracy and relevance, and also what AI benchmarks they are using to evaluate the performance. So all 3 presenters, Will, Oli, and Salome, will be addressing each of these conversations. So with that in mind, and given that I have extended a little bit of 4 minutes, I'll hand over to the presenters.
I'm Will. I'm the head of product strategy and impact at Oak National Academy. So I lead both on all of our product strategy work, but also on our kind of wider research and data and evaluation processes to make sure that we're really confident that the work that we're doing has that kind of meaningful impact on end pupils and teachers. I won't go into lots of detail about Oak, but there's a few important things that you should know about us. The first is we're a UK public body, so we focus very much on the English school system in our work. And because we're a public body, we really care about quality and safety. Those are massively important things to us. The second is an important strand of our work is focused on reducing teacher workload. That's certainly the strand where we've been looking at the application or the potential for AI the most. So that kind of end goal of reducing a teacher's workload is how we're trying to ultimately think about impact in this space. And the third thing that's really important to know is that in order to achieve that goal of reducing teacher workload, we've already created manually 13,000 odd lessons covering the whole of the English national curriculum for children aged 4 to 16. Those are the three things to know about Oak before we get into this presentation. Public body cares a lot about quality and safety, really focused on impact as defined by reducing teacher workload, and has got this significant corpus of existing content. So in that context, what are we aiming to do with Isla? And Isla is the name of the generative AI product that we've been creating. We are in essence trying to create high quality, high safety lessons that keep teachers in the loop. Now, this work sits within that existing impact governance framework that we've got. We know from our core product work that predates our AI work that if we can get a high quality, adaptable lesson in the hands of teachers, we have an impact and save them time. We've got the kind of theory of change to back that up. We've got the evaluation reports to back that up. We have high confidence in that statement. However, we also know that we can't possibly, even though we've created 13,000 lessons, have a lesson for every single one of the millions of different requirements that a teacher coming to our platform might have. So the challenge with Isla, the kind of potential for AI in this space, is to see whether using some of those generative AI mechanisms, we're able to meet all of those requirements by providing a lesson that meets those same standards for quality and safety that we've got for our core content. The great news is because we've got that existing corpus of content, 13,000 lessons, we've got a really, really good definition of what that quality standard looks like. We know codified what we think pedagogically a good lesson is, what its structure is, what its content is, and we've got a really good training set of data that we can use to assess whether or not this tool is actually producing content that we think meets those same standards that we would have for the content that we produce in-house. So really, a lot of our focus from an evaluation perspective is on that kind of input and output quality stage that you've just heard about, assessing whether or not the outputs of our AI tool meet the same quality standards as we've got for that kind of core corpus of content. So onto Isla as a tool itself. It's a fantastic product. We released it about 2 months ago. We're incredibly excited about it and we're getting fantastic user feedback about it. You can access it in its beta stage on labs.thenational.academy. It's free to use in the UK. I'm not, given the focus on evaluation, I'm going to talk to you at length about all of the different features and functionalities that it's got. I'll leave you to kind of explore those in your own time. But essentially, it provides a kind of co-creation workflow for a teacher to start a journey, provide a set of their requirements, things like the subject, the key stage, the content, the topic that they want to teach, provide more customized adaptations that they would like to see in the content, and step through a flow that will ultimately produce ready-made lesson assets that can be used into the stage. And you can see on the right-hand side of that screen there that once they finish that flow, they'll be able to take away a lesson plan, a slide deck, 2 quizzes and a worksheet ready to go. Again, these are the same assets that we already use, that we already provide and know have an impact on our end teacher users' workload when we've created them to our existing quality standards manually. The name of the game here is, can we get Isla to a place where we can be creating lessons that are more customized to our users' requirements that meet those same quality standards? So we've got 4 levers to do that. The first is prompt engineering. That is a term that I'm sure many of you will have heard before. We have taken it to reasonably significant extremes. The prompt that we use for Isla is about 9,000 words long, and it codifies all of the research, pedagogical and cognitive science research that we use to inform our own quality standards for the content that's created by our expert teachers. So we've gone reasonably far in that space. The second are 2 applied AI techniques, retrieval augmented generation and content anchoring, both of which depend on that core underlying corpus of content, but essentially, without getting too much into the detail here, provide the large language model that we're using to generate content. 2 applied techniques to provide the context to the LLM of Oak's corpus of content. We've got some an additional safety guardrail stage to make sure that any content that's created is safe to use in the classroom. And finally, the UX process, the actual journey through the product that we've created, focuses not on a kind of one-shot generation, press a button and here's a resource, off you go type flow, but really encourages teachers to take agency in the creation process, and at each step be reviewing and adapting the content to make sure it really does meet their needs. There was a question in the chat as to what I mean by manually. By manually, I mean, as a reminder, before we used any AI in any of our work, we had got 13,000 lessons created by expert teachers. So by manually, I just mean the lessons that were created by those experts as opposed to the kind of AI process itself. This is a very basic summary of what that flow looks like. We get an input from our expert user teacher. There's a step where we enhance and enrich that input query using those applied AI techniques, retrieval augmented generation, content anchoring on our content corpus. We take that augmented input, incorporated it into that 9,000 word prompt, and send it off to the LLM. And then when we get that response back, there's another stage, which I'm going to talk a little bit more about in a second agent there to make sure that we're really confident that that response meets our safety standards before it goes to an end user. So this is where it starts to get interesting. We've got 4 levers to raise quality, but we don't want to be just applying those blindly as we swap underlying LLMs, or we tweak our prompt, or we tweak the way in which we apply some of these AI techniques. How do we know if they're working? And this is where this evaluation step becomes really, really important. We use auto evaluation. So we have defined as an initial step 24 benchmarks. 19 of those are a Spectrum 5, a kind of Boolean benchmarks that we think summarize quality for us based on our kind of existing pedagogical research and are essentially a codification of the same quality standards that we apply to our internal expert teacher manual generation process. We use a second LLM as a judge to score the outputs of ILA essentially against those quality benchmarks to assess whether changes to ILA, making a change to the LLM, changing temperature, changing retrieval augmented generation application, changing a prompt, how those changes in quality as we move those quality levers actually affect the end quality output against these benchmarks. But once we've got an LLM as a judge and we've got this kind of definition, we also need to be confident that this auto evaluation process is in fact effective. We need a way of deciding whether or not our judge LLM is judging the outputs correctly. And to do that, we do a comparison of the LLM as a judge's scores against human evaluators. That allows us to apply exactly the same techniques to our LLM as judge as we do to the core ILA flow, things like changing the prompt, changing content anchoring, etc., to make sure that we think that this LLM as judge step is applying those techniques in the same way, scoring those outputs in the same way as an expert teacher would. Now, in general, we apply that auto-evaluation technique to batches of lessons. It's not part of the live run of ILO. It's used to assess on batches of produced lessons whether or not we've got, pulled those quality levers in the right way. But it could, in principle, be applied as a live part of the generative AI flow. And there's one place that we have already started doing that, which is with this asynchronous moderation agent, because we care so much about safety. And it's really critical that we're not putting into a classroom any materials that are not safe for classroom use. We have this second agent step that I referred to earlier, which is essentially another LLM as a judge, making a Boolean yes or no determination of whether or not we think that the output materials of ILA are safe to use, or applying a kind of content guidance flag. You heard this in the previous presentation, but I guess this all comes back to, for us, the importance of having that existing corpus of high quality, for us UK, but it was described earlier as local education content, both because that gives us that really high quality definition of what quality should look like, but also because that corpus enables the application of the levers that we have found to be most effective in an AI context to achieve that quality definition in the outputs of our products. And again, for us, if we have confidence that the outputs of ILA meet that quality bar, then the rest of our impact governance framework applies, and we're confident we are ultimately saving teachers time in their practice. Thank you.
Hi, everyone. My name is Salome Maru, and I'm a lecturer at the Department of Computer Science and Engineering in the University of Dar es Salaam. And today I'll be talking about an application called Swahili BookBot, just with the focus on how do we actually ensure quality to make sure that the application is actually usable to children. What is Swahili BookBot in this case? So this is an application that is supposed to help children learn how to read. So the children will have it on their phone, and then they will use it to teach themselves how to read. Ideally, the goal of the application is to make sure that children in schools or at homes or wherever can actually learn how to read, but in the absence of the teacher, hence a Swahili bookboard. So it's supposed to be a robot teacher that's supposed to help the children learning how to read. And this is a work that is conducted as a research project between the University of Dar es Salaam and Bookbot is an organization that is in Australia. So I do the presentation today, but the work is conducted between the two organizations. So what does it take to actually make an application that is AI driven and that helps children to read? So if you want the application to be able to read to the children, in the background, you're going to need a text-to-speech model. And this model is supposed to be able to see a word and recognize it and pronounce it correctly. But on the other side, you want the application to also be able to listen to the students. So, example, if the students are mispronouncing a certain word, the application should actually be able to tell, okay, this is a wrong pronunciation, and here is the right pronunciation. So technically, you need to have two models. One is, of course, the text-to-speech model, and on the other hand, you need to have the SAR model, automatic speech recognition. But with all of this, we all know that the input to these models is voice data, and for you to have anything that's remotely usable, you need to really have a high-quality voice data that you can use to actually train these models. So the focus of this presentation will be more on how do you actually ensure the quality of your input data, the voice data, for both the TTS and the ASR, and also how do you actually look at the quality of your output, because once you have a clean or high quality input and you do the training, you also need to check if your output also achieves high quality. And just to connect this to what Marho said in the beginning, is because if you're actually going to take this application in a real life environment or in any educational context, accuracy is really important. Like, you don't want to be misleading children while they are trusting that they can learn from your application. So how do we actually ensure quality? So I'll talk about quality from the two perspectives. So first the input and then the output. And this is first when we have to create the text-to-speech model. So with the text-to-speech model, the first quality assurance step you have to think about is the script quality, because this gives you what text you're actually going to use in order to produce your voice data. And the most important takeaway for this is that you have to make sure that the script actually covers all the phonemes in the language. Even the more rare phonemes, you need to make sure you have a considerable number of representation words within the script that's going to be read in the studio. Once you go to the recording place, this is you have an artist that will read the script that you just created before, that hopefully covers all the phonemes. Now, here we can think about quality assurance of the actual audio, and we can think about it from the two perspectives. So first, you have quantitative measures that tell you how good the audio quality is. And then you have qualitative measures, which is really just human judgment by listening to the audio and saying, okay, if this is something that is understandable to the human ear without any problems. So with respect to quantitative measures, we did some research and found that they are actually recommended metrics for measuring audio quality. And all of these have some kind of a threshold and say, okay, for example, the signal to noise ratio, that's actually how loud your environment is. So it actually measures for example, the person speaking vs the background noise. And of course, you need to be able to hear the person more than you can hear the background noise. But we also have measures, for example, this the total harmonic distortion. It's how much your devices are actually affecting the sound. And the two metrics, the dynamic range and the spectral flatness, really measures how the differences between the highest points of your audio and the lowest points of your audio. And then, of course, pitch stability, if the voice is stable or it's going up and down over time. And finally, STOI just measures, how understandable these words are. Like, can you make out a word from the audio that is actually recorded? So the interesting part that we found from our slide is that when we did the quantitative measures, most of these measures were failing. And this was mostly because of the aim of the application. So the application is supposed to be an app for teaching children how to read. So for the TTS, you need a very energetic voice, something that is exciting and sounds like it's exciting to the children. So if you have something that has the same pitch throughout, maybe it's not as interesting. So even though the quantitative measures were failing, the audio was still usable for this specific use case that we had. So we ended relying a lot on the qualitative measures, which is really just listening to the audio and figuring out which one is okay and discarding those that are, for example, too noisy or something like that. With the audio that was audited with qualitatively, then we moved to training the model, which is not going to be part of this presentation. But the interesting part is, okay, so once you've trained the model, how do you actually look at the quality of the output of your model? So a text-to-speech model will actually produce to you a speech, and you have to actually evaluate the quality of the speech that you got. So for this one, we went through a very manual approach of evaluating the quality of the audio that was produced. So we made a file, as you can see, that's an excerpt of our Excel file. And for each of these IDs, you also have a corresponding audio file that's got the ID. So what you do is we have around 4 people who are looking at the text and also listening to the audio, and then you can either accept or reject. And here you think about if you reject, you have to say which of these are actually mispronounced. So even though this was a very tedious step, but it's a step that was really necessary and especially helped us to understand which of these phonemes are problematic. As you can see, we marked this around. So for example, the KH was problematic in most of the scripts, or MV, like the more complex Swahili sounds were a bit problematic. So first, we got only a 56 performance with the first evaluation. And if you think about it, you can say, okay, maybe this is like a 50-50 almost. But the main advantage of doing this manual QA is that you get another set of synthetic data set that's already been verified by humans. And this means that you get like an extra input that's already been vetted, and that's a high quality input that you can send back to your model and then retrain your model to get a better performance. So while this was a bit tedious, it really helped in terms of creating the curated data set. How about the automatic speech recognition process? We want to train a model that will be able to listen to the students and actually transcribe what they're saying and match if they're actually pronouncing the words correctly. So the process really quickly is we didn't start from scratch, but started with training from a open source available voice data sets. And one of the most popular one is this Common Voice by Mozilla, which has a voice data for different languages. And after that, we now retrain it to add context with a recorded audio from actual children. And we recorded audio from around 200 children, and we have about 300 hours of recordings of that. How do you then do a quality assurance for the ASR model? So first, you would think, so for every input that you use, you need to have some kind of vetting to see that you're actually using the right input. And for the Common Voice data set that is freely available by Mozilla, they use crowdsourcing, where humans actually go and vet the data set. But during the recording, because the recording is done in a natural environment and you actually have children doing this, you need to be present to look around and listen to how they're reading, and mostly to catch mispronunciation. Like you have children who would have a problem with R and L, and if that goes into your data set, you might actually end up training a model that is incorrect. So here it was more of hovering over the children to make sure that we got the ones who can actually read accurately. And of course, a few other things like looking at the devices, proper positioning, making sure no one is hiding the mic or something. But the more interesting part is once you get the data now. So imagine you have this 300 hours of audio from the children, and you need to be able to vet it before you can actually use it for training. And here it's almost impossible to do it manually. So we used the pre-trained model from the Mozilla dataset to actually transcribe the audio. And then since we have the text that the children were reading, then we just need to match this and say, okay, the children were supposed to read like I am eating, and if the child reads I am eating food, then the transcription will be I am eating food, and then you will see that food is an extra added word, and then you have to drop it. So the quality assurance here was using that automated script, automated a language model that can actually transcribe the audio part. And then you discard anything else that doesn't match with your ground truth. For the output of the ASR, we use the model performance, and here for ASR, the most or the proven metric is actually the word error rate, which actually rates how many words were actually mispronounced by them or mistranscribed by the ASR. And with the data set that was, or with the model that was trained with the Mozilla data set, we had around 12%, and adding now the contextual data, the real children data set from Tanzania, that went down to around 2%, which is really a good result, as you have almost a 10% increase. And finally, these are lessons learned in a very summarized form. So with the text to speech, as you saw, we went through this tedious process of queuing, but this is really important as it helps you to really make sure that you have actually evaluated what your model is producing in the end. And with respect to the input, even though there is a lot of metrics published out there, it's really good to think about what your use case is and see if they actually make sense for that. And to be able to interpret these metrics, it's good to have a trained sound engineers, which is maybe not such a, you don't usually find sound engineers in development teams. The dev team usually has programmers and all that, but sound engineers might be rare. And we're starting to think that maybe it's good to research into language-specific metrics depending on the tonation of the language. It's recommended to record in a natural environment to make sure that the ASR is stable, so that even if a child is later reading in a noisy environment, this would not be problematic. And the labeling process should definitely be automated because it's really difficult to do 300 hours of labeling. And we found that the targeted data set improved the model. So this contextualization is not something that's oversold, but it's rather something that is really needed to get an application to work in a specific context. And I will end there. Thank you.
Oliver Garrett. I'm the Chief Data Scientist at AI for Education. I'm going to be talking today about some work we've been doing, which is about developing a specific benchmark for LLMs to compare different foundational models on a component of that we think is important, which is pedagogical knowledge. I'm just going to start with just a brief discussion on like why are LLM benchmarks useful. So one of the key points is that evaluating generative AI models is difficult because they're multifunctional, the outputs are unconstrained, and they're often part of a larger system which has many other design parameters that aren't actually part of the model itself. So one approach that we can take to solve this is to focus on very specific tasks or domains that are defined and run standardized tests on those tasks. The benefit of this is that it allows for comparison between lots of different models all on the same task, and it allows improvements to be tracked in performance over a period of time. A kind of simplistic way that you can think of lots of LLM benchmarks is they're effectively exams for LLMs, and often, in fact, they're multiple choice exams, and this is due to the making they're just much easier to measure the output of a multiple choice exam than it is to measure the output of a free response. Like all exams, they should be rigorous and fair, and more importantly, they should generalize to real-world application. So you can typically break this down into a data set, which is a fixed set of questions, which would be the same for every run of the test. A procedure for eliciting the answer and for measuring the answer, and a score for interpreting the answer. So as part of our ongoing work on this area, we have we're looking at one specific domains of AI functionality that are applicable to education. We identified a set of key domains broken down into different components that we think are testable, and we've made kind of early attempts to link these components to specific example applications. A product that's generating teaching materials would be important that it has good content knowledge, and that content should be aligned to whatever target curriculum or standard that it's the context of the application. And whereas a chatbot may need those things, but it would also need to have what we call pedagogy of interactions, which is more like knowing how to teach someone in an interactive way. Within this framework, we have we've done a review of what's out there in terms of existing AI benchmarks, the needs that we just discussed, and this isn't a definitive list of benchmarks, but we do think that there's a clear there are clear gaps in this space. A lot of them mostly not mostly, but a lot of them to do with pedagogy and content alignment. I think like for example, Google Learn LM, which is a model and a evaluation framework that Google developed, really is kind of targeting the idea of like pedagogy of interactions. But it's not currently like a publicly available benchmark. And as we heard earlier from Will, like Oak National are looking at quantifying content alignment of the outputs of AI systems. Today, we've focused on the idea of testing pedagogical knowledge, and that's what we're going to discuss now. As I was saying before, if you think of LM benchmark as being like an exam, then exam of pedagogical knowledge is kind of fall into the idea of a teacher assessment exam, a teacher training exam. We looked and we did quite a lot of looking for such things, and we found a really strong, like really good resource, which is from the Chile Ministry of Education, and they have very extensive teacher assessment framework using multiple choice tests, and we have 5 years worth of assessments. We are still not 100% through the process of extracting the questions from all of these, but we have over 1,000 unique questions that we've tagged for different areas of pedagogy. And that process also involves deduplication, it also involves translation and various other things. The questions cover a wide range of topics and different subdomains and different age groups. So I'm just going to really briefly show us a couple of examples. So this on the left, a 12th grade teacher is planning a class with the objective of determining the graphical representation of the inverse function of an invertible function presented graphically. Which of the following skills should students have achieved to meet the proposed objectives? And the correct answer is C. So these are the kinds of questions that we've extracted from this exam. So the one on the left is specifically teaching of maths, and the one on the right is teaching of biology. I think both high school. So we developed a framework for. So as I was saying in the earlier slide, you can think of the data set. So that's our data set, what I just described. Procedure is basically the process of running the test on the models and measuring the answer. One of the key aspects of a benchmark, which is supposed to compare models, is you compare lots of models. So we've got here 27 models that we've been able to evaluate on this benchmark. It runs on a wide range of models, open, closed source models, large, small models. The best model, which is O1 Preview, which is not that surprising, is 80%, which is not really close to perfect. So there's still a lot of room for improvement even with the best model. And the worst models, there's one that's 30%, but most of the bad models are in the range of 50%. So there's quite a large range of performance. So it's quite good at differentiating the different models. In reality, like for anyone who's developing a application, performance on a particular benchmark is not the only thing to consider. Of course, you have to think about, especially in a low resource setting, you're going to have to think about cost. So what I'm showing here is the same performance values from the previous plot, but with the cost log cost on the x-axis. So you can see the 10 cents, $1, $10 are the three main grid points on the x-axis, and that's per million tokens. The main thing to take away from this, I think, is that if you think about this kind of like frontier that goes from like the mid left mid to like mid top. So you've got these kind of clusters, so this kind of cluster on the left of Gemini 1.45, GPT-4 Mini, Yi Lightning are kind of like you're kind of cheap, but like actually quite competent. And then you've got more of a kind of mid-range cluster in the sensor top, which is kind of like the higher performance, but mid-range cost, and then you've got your kind of unrealistically expensive models on the top right. We think that this guide for making decisions, and you can see, for example, we had Claude 3.5 HiQ, which is quite new, actually kind of falls into a kind of a bad spot, which is like quite expensive and not much better, and actually worse than some of the really cheap ones on this particular benchmark. Going back to the slide where I showed the breakdown between the different categories in the data set, so we can also, we can run the benchmark on these different categories. So this just shows that the left plot is just running the benchmark on just purely on general pedagogical knowledge, and on the right is science pedagogical knowledge. You can see the general pedagogical knowledge is generally like slightly easier than the science one. This data set allows us to break it down at that level of detail. So just really quickly, also we're comparing here models run on the MLU which is a pre-existing content knowledge benchmark, just on primary and elementary and secondary maths categories against our maths subcategory of the pedagogical knowledge. And one thing that's quite interesting, so if you see on these models on the O1 Preview and O1 Mini, which they really excel at maths knowledge, they don't excel quite so much at the amount that they excel at math knowledge isn't quite as extreme as the amount that they excel at the pedagogical knowledge. So O1 Mini, for example, is 93 or 4% on the math content knowledge, but only like 68% on the pedagogical knowledge. So that kind of can be used to sort of show like areas where a model that could actually do better at teaching maths, even if it has a lot of knowledge of math. So this is that's a summary of where we're at potentially. We kind of view this as a larger piece of work. We're not just interested in this pedagogical knowledge. Like I showed in the earlier slide, we have this kind of framework where we're looking at different components we think are related to education. We'd like to be able to help guide decision making on quality assurance for each of those components. So in this example, the simplistic question that you might say motivates this is like, should you use a model for education products that fails the teacher training exam? For other aspects, you might say if your product is helping to produce assessments for children, are they correctly assessing the parts of the curriculum that you want it to be? And this could be based on, for example, the Global Proficiency Framework, something that we're actually looking at ourselves. And or if your product is using automatic speech recognition, does it work with children's voices in the country that you're in? So we want to kind of incorporate all these different aspects into a kind of decision-making framework. Yeah, that's it. Thanks.
We are now going to shift to a panel discussion for the next 20 minutes or so. And I'd like to welcome our three wonderful experts who are going to join us for this. So we've got Gauri Gupta from Central Square Foundation, Nicola Pitchford from Wicket, and Nissi Madhu from CT Hub. To get us warmed up before we jump into the discussion, could each please just tell us very briefly who you are and your organization, and then any quick reactions you might have from the presentations so far. So maybe Gauri, if I can start with you.
Thanks so much, Jared. My name is Gauri Gupta, and I lead the EdTech work at the Central Square Foundation. Central Square Foundation is a philanthropy working in school education in India. And in addition to foundational literacy and numeracy, one of the focus areas for us is EdTech, where we're trying to figure out how technology can help children from low-income backgrounds learn better. And standards has been something that we care deeply about, and we've been working on for a long time. Very excited by what I've heard so far. But I just do want to call out that, what you hear today is a very, very curated list of organizations who care deeply about quality and standards, right? And that is not true for the entire ecosystem. And hence, I think the topic is extremely pertinent, right? That how do we create quality standards for AI so that, our children are getting the right quality of solutions. Thanks, Gerard. Handing it over to Nicola.
Thanks, Gauri. I'm Nicola Pitchford. I'm the head of quality assurance at Wicket, otherwise known as the International Centre for EdTech Impact. I have a background in developmental neuropsychology and scholastic acquisition. Until recently, I was a professor at the University of Nottingham in the UK. And for the past decade, I've been working assessing the impact of EdTech for supporting foundational learning, so raising literacy and numeracy outcomes, mostly in low and middle income countries, but in other contexts as well. I found the three presentations today fascinating, and I've got particular questions I'd love to ask the presenters, but I think my main point comes down to AI is only as good as the content and algorithms on which it's based, and that also includes the assessment frameworks. And I think we need to look very carefully at how content is curated, and whether the algorithms are suitable in particular contexts. And that doesn't just mean a location. It doesn't mean a geographical location necessarily. It means the context of development itself and the development of the child, the learning development, not necessarily the country's developmental status. I'm very happy to talk more about that as the discussion progresses. Thank you.
Thank you, Nicola. Hello, everyone. Good afternoon. My name is Nisi Madu, and I'm managing partner at CC Hub, Co-Creation Hub, and we are an innovation center in Sub-Saharan Africa. And our focus essentially is on leveraging technology and innovation to drive African prosperity. We do a lot of work in education with a focus on how technology can be leveraged to improve learning outcomes for children, starting at the foundational learning level, but going all the way even to tertiary education as well. And we do a lot of work supporting edtech startups or innovators, those who are building for edtech within the continent, and ensuring that this products that they're building are not just nice in terms of the technology, but that it's actually adopting effective learning science theories, and it's very pedagogically rigorous and ensuring that it's actually leading to those learning outcomes. It's been really exciting listening to all of the presentations, and Nicola, you took the thoughts right out of my mouth, essentially, in a cross-cutting theme that I saw across all of the presentations, is the fact that quality content is very important in terms of how this AI, algorithms or platforms are able to deliver on learning for our children, but essentially also that the contextualization matters. I think something else I thought about that that made me chuckle a little bit is that we talk about so much how powerful these machine systems are, but there's an important human element in ensuring that we're still able to get that quality of output from this. And, it's one of the key things, of course, in thinking through benchmarking and ensuring quality of AI tools. How do we include humans in such a way that it's not as tedious as colleague from Bookbot mentioned, but then still ensuring that we're able to get the best quality of output? Thanks.
There's no world we would like to see in which these systems completely replace the role of teachers, and that human element is always going to be absolutely critical. And so it's a matter of how to figure out how they can work together in a way that's going to be most supportive of better learning outcomes. Gori, you mentioned the point about how we're in a sort of little bubble here of people who really care a lot about this topic, but it's not a common concern, unfortunately. And we saw the data from Maho earlier about how few of the products in the evaluation, in the landscape mapping we did, are actually publishing anything on this, and that's a really important topic I want to come back to in a bit. But before we get there, I thought we would start just by discussing the sort of quality assurance frameworks more broadly, and obviously EdTech quality assurance frameworks are not new. And Gori, the sort of TONA standards you've developed are, I think, are incredibly thoughtful and have been getting a lot of traction in India and increasingly beyond. But we do now need to adapt and expand them for the advent of AI, and that's what I wanted to sort of discuss with you all first. So I guess the question to each of you is how do we need to think about that evolution, and how do we need to adapt how we think about EdTech standards for AI EdTech standards? And maybe Gori, I'll start with you, given I know you're thinking about this with TONA.
Yeah, absolutely. No, thank you. Thank you for bringing this topic up. I think it's very close to our hearts, right? I think we were at some stage stabilizing on the quality standards for EdTech, right? And then generative AI suddenly comes in, and we have to start all over again. Because what is happening is two things, right? One is the fact that we see very new use cases of EdTech emerging with the use of generative AI, right? And the second is that ultimately now with edtech products, the content is not static, right? It's dynamic content, and it's dynamic on with a lot of nuance. For example, the relationship between inputs and outputs, right? That was previously considered to be static is now constantly changing with every interaction, right? Similarly, nature of interactions was previously pre-authored, rule-based, right? But now we are starting to see more human dialogue. And because of this, right, while we are able to, in some ways, ring fence the output, we do see, outputs being prone to inaccuracy. And that is dangerous, right? When we are exposing children to, output that is dynamic and has not been tested. And hence the need to create benchmarks where we are able to assess the quality of the output. And the way we think about is, Jared, is to say that, look, there is the one way where we are in some ways evaluating the underlying LLM and the tech stack that goes with it, right, which is responsible for creating the output. And then the other part is that where we are actually evaluating the output generated by the edtech solution. And I think, in our approach towards building standards for edtech, which governments, which are powered by AI, and the way in which governments could use these standards, I think our approach is more to focus on the quality of the output, which is generated by edtech solutions that are powered by AI. Because I think with the use of AI, what is happening is that there's coming into play all the capabilities of the Gen AI models around, generation, reasoning, translation, transcription, synthesizing, extraction, etc. And all of those are feeding into the output of the edtech product, right? So originally, with the Tulna framework, what we were able to evaluate was saying that, look, what are the criteria to evaluate the content of the product? What are the criteria to evaluate the pedagogy of the product? What are the criteria to evaluate the technology behind the product? But now within each of these dimensions, the capability of AI is kicking in. And hence the framework, needs to look significantly different in order to assess the quality of output. I'll just pause there, but would even love to discuss, how. So there's the one question around what needs to get evaluated, but there is an equally, complex question on how it will get evaluated, because the method of evaluation, in my mind, also needs to drastically change.
There's such a broad number of use cases for AI in education that this has to be applied to, which is another real complicating factor. Nicola or Nissi, would either of you like to add to or build on or respond to that, or share your own thoughts on that topic?
Yeah, I'm happy to. At the centre, we have a 5Es framework, which is designed to give a holistic and comprehensive evaluation of edtech tools, and we see AI tools as being part of a broader range of edtech tools. But there are specific areas that edtech AI brings additional sort of questions to ask within each of those areas. So in terms of efficacy, we're looking very much at adaptive learning algorithms and how we need additional data on how effective they are at enabling children to learn who start at different levels, who might progress at a different pace, and how good essentially those adaptive learning algorithms are at promoting learning and enhancing learning. I think it also brings in, it links to the question of equity there, because certain algorithms will benefit certain children and certain types of learners more than others. And we know that development is not linear. it's a nonlinear process. We also know it's dynamic, and we know it changes over time, and the way in which children learn changes over time depending on the skills that they're acquiring. So those algorithms that are embedded within AI are absolutely critical for their efficacy and also for equity. We also know that a lot of the content that is based within some products is based mostly on sort of Western models of learning and Western content. And I think when considering the applications to other countries, especially low and middle income countries, we need to make sure that the content is suitable for the context in which it's going to be used. It's really important that teachers have agency in knowing that the content is applicable for their environment. There are problems with ethics, and there's a huge question about data security. And I think, we need to be very, very careful as to how we're using data that's generated through AI and how we might use things like performance patterns, how children interact with AI, to say give access to their identity. There are a whole range of issues of interactions with AI tools that pose real challenges to data security and ethics that have broader connotations that need to be thought through. And we also need to look at effectiveness, so how teachers are interacting with them. I think there's cultural implications here about how different cultural beliefs and that can influence the adoption and interactions with AI and teachers. And then in terms of the environment, the more powerful the tools are, the energy that's required for running those tools. So we tend to take a holistic approach, but there's sort of areas where within our approach, AI poses particular challenges. Thank you.
Nissi, anything to add?
Yes, absolutely. I think that Guri and Nico have touched on a lot of points I wanted to mention, but I think a key thing that I'd like to highlight here is prior to this, usually when we evaluate edtech tools, it's sort of a, to what Guru was saying about it being static, you evaluate, here are all of the components. But now we're going to need to have or design a more continuous sort of assessment process with AI because of how quickly that evolves, and that in itself brings a lot of complexity. And just that continuous assessment framework, for lack of a better way to describe it, would also need to take into consideration a lot of nuances and use cases. And like Nicola said, including creating case-by-case scenarios of different learners and what level they're at, and just seeing how these AI tools respond to them based off of that. Another key bit as well is to what Guri had said around, do we focus on just the quality of the output, or do we also look at the engine and the design of all of that powers this output? And that bit of the algorithm being very important as well in terms of just thinking about how it's put together and the best way to optimize to be able to get the best sort of outputs from the content that we have and we're training these models on. And the last bit I'll add on that is we know that the quality of the data that we use to train this and also evaluating that is really important. And so all of the regulations and acts that has to do with how this data is accessed, how it's used, is also important to ensure that we are evaluating these AI solutions based off of that. And this can even bring its complexities because as you go from country to country, for instance, within SSAs, we're seeing a lot of countries setting up their own data protection and regulation acts, and all of the nuances within that is different. It means that if a particular AI product will then be going into multiple countries, then we need to take into consideration the nuances of those regulatory acts as well. I think those are just a few things I would add in relation to all of the things that Guru and Nico.
On time, but I'd love to come back to come back to the point that we need more people to care about this, right? Like we can't have this just be a little bubble that we're in a kind of talking and thinking about quality. And we saw some of the data from Maho before, that there are AI edtech products out there that have 10 million users but aren't putting out anything in terms of whether or not they're good at what they're supposed to be doing. So I guess the question to each of you is how do we get to a world in which this becomes a driving force in decision making, for consumers adopting products, for governments adopting products, for developers developing products. How do we get closer to that world? And maybe Nissi, I can go back to you because I know that this is one you probably think a lot about.
Sure. Absolutely. And so that's something that, at CCO we're working on for at SSA. And this is not just for AI products, Jared. And to what Gori had said about these organizations, a group of us here, organizations that really care about the quality of solutions that are going into our schools. Currently in SSA, we do not necessarily have a common reference point of what good tech looks like, and then of course extend that to AI. So there's a lot of collaboration that's required, and that's because all of the different stakeholders who are important are building in silos. And so one of the things that we're looking to do as well in creating a common QA standards framework and evaluation process for edtech products, including AI-focused edtech products in SSA, is bringing together all of these different stakeholders from the very get-go as we're designing it, government, and taking into consideration from their own perspective what are the types of information on standards that they would require to be able to make decisions. Because one of the important things that we found in our work is that when you're speaking to different stakeholders, what they're looking to, their understanding or their perspective is different, and how they're looking to use that information in their own perspective is different as well. And so if you're not speaking that language, then you're basically cutting out this very important group. And so in that spirit of collaboration and in the work that we're doing is taking into consideration all of these different stakeholders, their perspectives, collaborating on the design of this framework and ensuring that each stakeholder is able to get from their perspective the kind of information that they need to empower them to make the right decisions when it has to do with edtech and AI-focused edtech products being used within our schools and by our teachers and children.
Bit cheeky and take a bit longer than the one minute that Marta's given us, but go ahead, Gori.
I think we've had some experience of trying to bring together demand and supply, right, in India to converge on a common set of standards. Because the way we approached the adoption of Tulna was that we started going to governments and evangelizing with governments the need to include Tulna standards within their RFPs that they were putting out for ICT. Because originally the RFPs that governments would put out would only, talk to quality for the hardware. It would never talk to quality that was required from the edtech product. And through, talking to governments and getting them to include the Tulna standards within the RFPs, product companies started realizing that, these were standards that were important to comply with. In fact, there was one government RFP where they said that, look, if you've been evaluated independently by Tulna, you get extra marks in the RFP. And that's the time when we got a huge number of edtech companies wanting to get evaluated by Tulna. So I do think that, in addition to creating the standards, it is very important to think of the demand side. And in our context, because government is the largest purchaser of edtech, especially in the context of low-income children and students, that has been our primary audience, right? But I do think investors as a community and even retail consumers need to be sensitized about standards, because that's the only way in which we will be able to drive supply, to certain benchmarks.
It can be critical. And Nicola, anything to add?
I think that Nissi and Guri covered so many really good points there. I think the thing that I would say from my experience of working with edtech organizations where the focus is very much on the child, right, is that when the focus is on the learner or on the child, then quality is necessary. And those organizations whose focus is based on enhancing learning are going to want to know what works, how it works, how can I improve learning. They're naturally asking those questions. So it's a mindset of organisations that I would encourage, to promote and to shift, that the focus has to be on the learner. It has to be on the learner at all points. So even EdTech products that are designed to enhance like teacher practice and time and so forth, ultimately that should lead to enhanced learning outcomes. And I think when the focus is on the learner, quality is just a necessity. It just has to be there. So I would posit a mindset shift.
Started in a conversation that we could carry on for a long time, but I think we'll have to wrap up there, unfortunately. So thank you so much to the three of you, and I think Paul, it's over to you for any last Q&A and conclusions.
I just did say, does anybody have a question for the panelists or for any of the speakers? If so, please put your hand up now. I've seen one come up. Amina, would you like to come in for a question? Please say who you are and who the question is kind of addressed to as well.
Hello, everyone. Thank you very much for the very interesting session. A quick question maybe to everyone. I was wondering, how familiar are you with other big initiatives like UNESCO's and the movement for AI? Thank you.
Oh yeah, of course. And I think a question addressed to everybody is quite difficult. Certainly from our side, as you can see, a lot of what we try to do is do a lot of convening and pull people together and make sure that this is built on all the major frameworks and initiatives. So yes, certainly from our side, we're very familiar with the work of UNESCO and UNICEF and trying to build on all the great work that's been done prior, because this is an advance in the kind of edtech tools from our viewpoint. It's not starting from afresh. So yeah, certainly we're trying to work with them and work collaboratively as much as possible. Anyone want to jump in on that one? Just in the interests of time, I might not open it up again to all four panelists, but if anyone disagrees with me, please jump in. Any other questions from the audience? Salome, there was a specific question for you just on the hours of data and audio that's used. So I think in this and in terms of what next, one of the big things we're going to try and do, I put in the chat, is work on getting high quality training data for some of these voice models for various languages across sub-Saharan Africa. One of the big things underpinning it is obviously the quality of the audio recording, and I think you mentioned that the range of phenomes was really important, but can you just say quickly how many hours of recording are needed, like how much people need to get?
We have a lot of lines. I have to verify the number of hours, but we went with around 300 lines. That's about like 5 to 10 words in each of these lines. And the reason that we could go with such low amount of data is because the application, the model already was pre-trained on an existing open source database that was like 1,000 hours. But it wasn't like, I think it was a Kenyan Swahili, someone reading the Bible beginning to the end. And then that was a lot more hours. So then for us to contextualize, we used the way less data. But for the ASR, we have around 300 hours. 300 hours from the children, and in an uncontrolled environment. You want the model to have a bit of noise so that later, if they're going to use the application in a noisy environment, it shouldn't be a problem for the ASR to catch as well.
There's another questions which came in just in terms of what's a human equivalent for the Chilean tests, and there's a kind of item on our to-do list to figure that out and figure out what that kind of failure mark is. One of the things we've been discussing kind of internally is there's a big debate in education over measurement and are we being reductionist when we're trying to measure. And this comes across worries by trying to standardize, you put all of the attention on that. And one of the things that certainly we've been thinking is, passing these tests are not sufficient to be high quality. And it's a big framework, and you've got all these different components and different contextual factors. but failing the test should probably disqualify you. So I think this does open a big question in terms of what do we mean by failure. I won't put that back out there, simply in the interest of people's time, but just to flag that this is something we're thinking about a lot, and if anyone's got any clever solutions or ideas, please feel free to kind of reach out to us. Just in the terms of kind of what's next, basically, we're going to be continuing these work on benchmarks. As Mahal said at the start, very grateful to support from the Jacobs Foundation. We've just got more support from the FCDO to continue the generation of new benchmarks. So we're going to be working in the technical details of getting these right. And I should say they're actually really difficult to get right, and it takes a lot of work and effort. One of the first questions we're going to face here is, where next? Do we go deeper into the ones we're doing, or do we do new ones? So we'll probably come back out to the community to crowdsource ideas of where do we think the most important components for the next wave of benchmark creation is. Obviously, if anyone knows of any other benchmarks, like for automatic handwriting, we were discussing yesterday, there was a Kaggle competition. If other people are doing it, wonderful, we can curate. If no one is doing it, we can create. So we'll come back out for that kind of discussion. Alongside this, we're going to be thinking through the communication of this and the usage of this. And I think Nissi and Guri touched on two very important points, which is one, if we can get this used in procurement and advanced market commitments. So if you meet these standards or engage with these standards, we will score you highly in our procurement. That will have a very powerful market shaping and market shifting kind of influence. So we need to think through then, how do we make these simple, tractable, and very user friendly? Because people don't have time, they need something which communicates clearly, while at the same time being conscious of the complexity. So we're going to start by publishing the scores on our pedagogical content knowledge, and at the same time running this alongside a decomposition of MMLU, which Oliver didn't go into, but we've now got scores on pedagogy of, say, geography and the content knowledge of geography from a child's perspective. So we're thinking through, and we'll be publishing over the next few weeks, a leaderboard for the specific use cases and the specific things we have. So please keep an eye out for that. As I say, we're trying to balance here the need for simplicity, because everyone asks us, what's the best LLM for education, with the complexity and the complexity of the different use cases. But keep an eye out for our new leaderboard. It is getting dominated, I think, by O1 at the moment, which is why we're also looking into what is the most cost-effective solution, what's the best open source solution. We've got all the infrastructure set up now to run this for any kind of new models. So if people are coming across new models, new innovations in architecture, please get in contact with us and we can run this and update it and make sure that's in there. So anyway, that's the kind of pipeline for us over the next few weeks, on the few months or on the benchmarks, and then we'll be continuing our collaborations with all the great people on this call on the wider quality frameworks and thinking through how do we apply these quality frameworks to the emerging tools. So we have got a little bit over on time, but I just want to thank everybody. I know this is quite a niche topic, but we had 90 people turn up at one point, which to me, looking across the development sector, says that it's important and people want to know. So the more we can be communicating what we're doing here and sharing our learning and experiences, the better it can be. So once again, thank you all for your time, and we will speak to you all soon. Thank you.